Welcome to online classes. I am Shilpa, lecturer in DCME, working at Dr. B.R. Ambedkar Polytechnic, Karimnagar. In previous lecture, we discussed pass by reference that can be done using two methods. One is using pointer variables, that is by passing address at the time of function call, and using a pointer variable at the time of function definition. That is one method to pass by reference, and second method that pass by reference can be possible by using reference variables. These are the two different methods which are used to pass by reference. And we have seen, we discussed even an object can be returned from a function with example program. So in today's lecture, we are going to discuss even an object can be returned from a friend function. In previous lecture, we discussed how an object can be returned from a member function. In today's lecture, we are going to discuss how an object can be returned from a friend function. And also we will see one example program for that, and after that we will discuss function overloading. That means here on completion of this lecture you are able to know how a friend function return an object. Okay, and we will see one program also, and after that you can able to know what is meant by function overloading, and some example programs on function overloading. Here, returning objects from friend function. As we discussed in previous lecture, the member function, that is sum, which accepts two objects of the class time, and it performs or it adds the times of those two objects, and it returns one more object. Okay, that is which consists of sum of these two times, right? So here that is done by using a member function. Now even a friend function, obviously we know that a friend function always have an object as its argument. A friend function always have object as its argument. So here we are using this friend function to return that object. That is obviously to accept object as arguments. So now after performing some operations on the objects which we pass to the friend function, we are trying to return the resultant object as its return value. Okay. So a function can not only receive objects as arguments but can also return them. An object can be returned from a friend function. In previous lecture, we have observed the member function can return an object. Now we will see even a friend function can also return an object as its return value. So for that, here in order to implement that concept, here we are going to declare one program. We are going to write a program, that is class complex number. So here I am using friend function to add two complex numbers. As we know, complex number consists of two parts, that is real part and imaginary part. For example, 2 plus 2, 2 plus I 5. That means here in this example 2 is the real number, real part, and 5 is the imaginary part of that complex number, right? So here I am taking two variables, real and imaginary, to hold that real part and imaginary part of the complex number. Okay. So here I am using one member function, that is input, which takes two arguments and which assigns these arguments to the private data. private data, that is real and imaginary. And one friend function, of course friend function is different from member function. So here I am defining one friend function, that is sum, which accepts two objects of the same class, that is complex, as arguments and return a complex number and return a complex number. Okay, this is friend function. And I am declaring one more member function, that is show. For that show, even I am again passing the object of the same class, that is complex. Okay, so here in this example, I declared one class complex with two data members, real and imaginary, and two member functions, input and show. Input which is having two float arguments and which is used to assign those two float arguments to the private data members. Okay, and one another member function, that is show, which accepts its own object as argument and which displays the values of this real and imaginary. And one friend function, the name of friend function is sum, which accepts two arguments of the same class complex and it returns an object of type complex. Okay, now see the code for input complex and show. Sorry, sum and show. So return type of the friend function is complex, and as this is a friend function, okay, we need not to use scope resolution operator as for defining the member function here show. This is a friend function, that's why simply that is like normal function only. There is a clear difference between friend function and member function. If that is the member function, that we need to follow the syntax, but here this is a friend function, so we need to define this friend function as normal function only, though that is declared in class and can access the private data of the class. Okay, so here complex is the return type of this friend function and sum is the name of the friend function, and it accepts or it receives two objects of the class complex. That's why complex C1 comma complex C2. And what this friend function do? Simply as this complex number is having two parts, real and imaginary parts, here it will take two objects C1 and C2. C1 is having its real and imaginary parts, and likewise C2 is also having its own real and imaginary parts. So in this sum function, what I am doing is I want to add real part of C1 and real part of C2 and storing as real part of some other object, that is C3, and I am trying to add imaginary parts of C1 and C2 and I am storing them into the imaginary part of the object C3, and after adding real parts and imaginary parts of C1 and C2 and storing in C3 object, I am returning this object from this friend function. This is the code which perform this task. Complex C3 and C3 dot real equal to C1 dot real plus C2 dot real, and C3 dot imaginary equal to C1 dot imaginary, C2 dot imaginary. And after finding real and imaginary parts of the object C3, I am going to return the C3. Okay, and this is only the definition of friend function. Now I want to define the member function show, which is having one argument object as its argument. Okay, and return type of that show is void. See here, the return type of this show is void. So void, and then class to which this show method belongs, so that is complex. And as this is the member function which is defined out of the class, I need to use this scope resolution operator followed by the name of the function, that is show, and arguments list, that is complex one object. Okay, and here what is the definition of this show function? Simply it prints these objects real and imaginary parts by joining them with plus I, because complex number always represented in this form only, 2 plus I 5, like that. That's why here I am printing uh, the objects real part and plus I and objects imaginary part. This is the definition of show member function. And in main what I am doing, so here I need to make use of all the class members. That is, I need to assign values for real and imaginary data members by calling this member function, that is input. Okay, and after that I need to pass two objects as arguments to the friend function sum, and after that I need to call the show function by passing one argument. So for that here I am declaring three objects C1, C2, C3. Okay, and by using this C1 I am calling the member function input by passing real and imaginary parts of object C1, and likewise for C2 also I am passing some real and imaginary values by calling the input function. And after getting imaginary, real and imaginary parts or values of these two objects C1 and C2, here I am passing them C1 and C2 objects as arguments to the friend function sum. As this is the friend function, we need not to call that sum with any of these objects, because that is a friend function. Friend function can be called like normal function. This is not a member function, so we need not to call the friend function with any of these objects. Okay, and as this sum, that is friend function, is returning an object, I am storing the return value into the another object, that is C3 here. C3 equals to sum of C1 plus C2. Right, this is equivalent to C3 equals to C1 plus C2, that is C3 dot real equal to C1 dot real plus C2 dot real, C3 dot imaginary equal to C1 dot imaginary plus C2 dot imaginary, that is equivalent to that. And after getting the sum of C1 and C2, now I want to print C1, C2 and C3 by calling show method and by passing these objects as arguments. Okay, in order to print the C1, I am calling show method by passing C1 and through C1 object only. Likewise for C2, passing C2 and calling the show function through C2 method, C2 object. Okay, likewise this also. Now we'll open Turbo C++ and we'll execute this program, that is how a friend function can return an object. New, okay, include iostream.h hash include Tonya.h. Okay, and going to declare the class complex complex and two variables real comma imaginary. Okay, private members, that's why I am not specifying private or anything, otherwise you can use this access specifier. Okay, and public members, here I am declaring two member functions and one friend function. So first member function is void input, which accepts two arguments of type float, float x comma float y. Okay, and assign these x and y to these two variables, real equal to x, imaginary equals to y. That's it. Next, I am declaring one friend function. The name of the function is sum. Of course, it returns complex object as its return value, that is complex. Okay, and the name of the function is sum, and it accepts two variables, complex c1 comma complex c2. Okay, and one more member function, that is show, which accepts one variable. Okay, I am not defining these two functions in class itself. Out of the class I want to define. So here first one, I need to define the friend function sum. So the return type of the friend function is complex, and the name of the friend function is sum, and the arguments are complex c1 comma complex c2. Okay, now write the definition. I need to declare one variable for the class complex, that is c3, and I need to get the or calculate the real and imaginary values of this c3. That's why c3 dot real equal to c1 dot real plus c2 dot real. Okay, likewise c3 dot imaginary equals to c1 dot imaginary plus c2 dot imaginary. Okay, we are adding the real parts and imaginary parts of c1 and c2 into c3. Now return c3. Okay, this is the body of friend function. Now we need to define the member function show out of the class. So what is the syntax for defining a friend function out of the class? Return type, that is void, and the class name complex. Okay, scope resolution operator, and the name of the function, that is show, along with the arguments complex c. Okay, what it do? Simply it prints real and imaginary parts of that object in the complex number format. C real, okay, plus I and c dot imaginary, okay, and L. Okay, so simply here by using this show method I am printing the real and imaginary parts into the complex number format. And after that I need to write the main method, main function, int main, and here I require three objects, c1, c2, c3. Okay, and by using through c1 I am calling the member function input by passing values 3.2 float values and 2.5 like that. C2 dot input again to float values. Okay, so we passed values for these two objects. Now we need to calculate the real and imaginary values of the object is C3. That's why C3 equals to, we need to call the friend function sum by passing these two objects as arguments. Okay, and that's it. Now I want to print all the complex numbers, that is these three complex numbers. C1 equals to, okay, C1 dot show, and we need to pass one object, that is nothing but C1. Okay, like that. Now print C2 equals to C2 dot show, because this is a member function, that's why we need to call the member function through only object of a class. Cout C3 equals to C3 dot show, pass this C3. Already we calculated using the friend function, right? Get ch and return 0, and close of the main, and I will even use CLR SCR, right? So I think no errors. Let me save the program. Uh, Save. It is the program friend function object returning from friend function. Obj from friend. Okay, obj from friend. Okay, compile the program. 0 errors. Run the program. 3.1 plus, sorry, 3.1 plus I 2.5, 4.5 plus I 6.5. So by adding a real part 3.1 and 4.5, we will get 7.6. That is C3 real, and 2.5 and 6.5. 6, 7, 8, 9. That is imaginary value of this C3. Okay. So that is here what we observe. Even the friend function, okay, can return an object. Okay, this is sum. Clear? Even you can change the values here, and you can observe the difference if you want. 2.0, anything. Otherwise at runtime also you can able to read values, but here at compile time only I am providing values. If you want, you can provide values at runtime by including some more code. See here, real part 8 and imaginary part 2 plus 6.5, 8.5. Right? This is all about friend function returning an object. Okay. Now next topic we need to discuss is function overloading. Function overloading. Before going to function overloading, what is uh, what actually it means function overloading, and what which subtopic for which it is subtopic. Okay, so that is here. First, before going to function overloading, first we need to know what is mean by polymorphism, what are the different types of polymorphism, under which category this function overloading will come. Okay, so for that, what is mean by polymorphism? Poly means many, morphisms means forms. That is, having more than one form is called as polymorphism. That is a Greek word. So here, polymorphism means nothing but the ability to take more than one form. The ability to take more than one form is called as polymorphism. And an operation may exhibit different behavior in different instances. The behavior depends upon the types of data used in the operation. Okay, that is, for example, same operator plus. If we use this plus to add two integers, obviously it performs addition on these two integers. Okay, if we use plus for two different strings, okay, then the same plus will not add these two strings. Here it appends the second string at the end of the first string. Okay, so an operation may exhibit different behavior in different instances. Same plus, but in order to add integers it behaves like something else, and for adding two strings it behaves like some other. Okay, the behavior depends upon the types of data. In the first case, the type of the data is int. Okay, and the operation is only place. And in the second case, the type of the data is string, and operation is place only. But on different instances and on different data types, the same place is acting differently. Okay, that is having more than one form. Polymorphism is used extensively in implementing the inheritance. Normally, this polymorphism is used for implementing the inheritance concept. So here, types of polymorphism. Types of polymorphism. So there are two types of polymorphisms. First one is compile time polymorphism, and second one is runtime polymorphism. So compile time polymorphism is divided into two types, that is function overloading and operator overloading. And runtime polymorphism is called as can be implemented using virtual functions. So in this case, this operator overloading is different, because here in operator overloading we provide different meaning for the same operator, like for place, adding, same place on strings, appending. Okay, we are providing different meanings for the same existing operator. So this is different, but when you compare this function overloading and runtime polymorphism, these are on functions only. This can be performed on functions only. Here the function prototype and function name are checked at the time of compile time, and whereas the function names and the prototype of the functions are checked by the compiler at runtime. Okay, so these two normally on functions, function names. These two depends upon the function names, and whereas here this operator overloading depends upon the operator, existing operator. Function overloading and virtual functions depends on functions. Okay, so compile time polymorphism, one type of compile time polymorphism is function overloading. In this class, now we will discuss this function overloading with some example programs, and after that we will check what is virtual functions in next class. So, function overloading. A single function name can be used to handle different members and different types of arguments. Different number and different types of arguments. It is nothing but a particular word in having several different meanings depending on the context. Using a single function name to perform different types of tasks is known as functional overloading. Using a single function name and performing different tasks. Okay, in function overloading, function name will be the same, but these function names are these functions which are having the same name are differ in number and type of the arguments. Number and type of the arguments. Here, for example, if there are four functions with the same name, add, but these four are differ in number and type of the arguments. Number and type of the arguments. Then that is called as function overloading. Okay. Now, overloading refers to the use of the same thing or same function for different purposes. We use the same function name for different purposes. And in C++, two functions can have the same name if the number and or type of arguments passed is different. Number of the arguments and type of the arguments may be differ, but we can use the same function name for more than one function in C++. We can use the same function name to create functions that perform a variety of different tasks. This is known as function polymorphism or function overloading. And we can design a family of functions with one function name but with different arguments list. Okay, so add function with different number and type of the arguments are differ. Okay, we can create a family of functions. Because why we are calling them as family? Because here all these functions names are same. Okay, like if we belongs to the same family, our surname will be same. Okay, likewise here we are creating a family of functions with one function name with different arguments list, and the function would perform different operations depending on the argument list in the function call. That is, if we are calling, if we are passing two integers for the add function, then it call or it invoke the appropriate function which is having add as the function name and two integers as its arguments. Okay, as there are some family of functions with the name add, as there are set of functions with the name add. Here the function called directly or exactly matched with the function definition which is having the function name as add and two integers. The current function to be invoked is determined by checking the number of arguments and its data types as we discussed. Okay, so this is called as function overload. Normally, why we need to go for this function overloading? Normally, why we need to go for this function overloading? So, if our program is consisting some number of functions, okay, if we want to provide different names for or unique names for all the functions in our program, it may be hard to remember all the names, and also include if all the functions are mostly performing similar tasks. Similar tasks. Okay. So if that is the case, if we are using different names for all the functions in the program, it may be difficult to remember the function names when in main if we want to make use of a particular function. Okay, in order to overcome that or in order to reduce the number of function names to be remembered, here we are using same function name with different number and different types of arguments. That is only the reason why we need to go for this function overloading. Okay, in order to overcome the burden of remembering more names, function names, we introduce this function overloading. Okay, that is only the main reason. And how we can declare the function overload. So if you see this, here these three functions are having same name, add, right? And first add is having two arguments. Okay, even here third function, it is having two arguments. Okay, here the name of the argument and the number of the arguments, name of the function and number of the arguments same in first function and say third function. Name of the function is same and number of the arguments are same, but they are differ in type of the data type of the data. Okay, here the type of the data is int, and here the type of the data is double and char. Even they are different return type. Okay, and here int return type is int, same like first function declaration only, but even it is accepting two integers. Along with these two integers, it is also accepting one more float variable, float argument. Okay, so like that, function overloading is the one which is having same function name with different number and different type of arguments. Same function name with different number and or different type of arguments. Okay, and here one thing you need to remember is, if the return type is differ and everything is same, that is the prototype of the function is same, but if the return type is differ, we cannot say that is example for function overloading. Function overloading, for example, here int add int a comma int b, and float add int a comma int b. Okay, in this case, if, for example, if that is the case, int add int a comma int b, float return type is float and the prototype is same, add int a comma int b. We cannot say that is example for function overloading. Okay, though the return types of the functions which we discussed differ, they are not written as function overloading example. That is not a function overloading example with two functions where they are differing only its return type. That you have to remember. Okay, they are not treated as function overloading example, though they are differ in only the return type and everything is same. Function name is same and number of arguments and type of the arguments are same. Okay, that is not an example for function overloading. Now we'll see one example program for function overloading. So here in this example we are declaring four functions, and all these four functions return type is void only. Of course, we need not to bother about this. We need to concentrate on number and type of the arguments only. Okay, and name of the function is add, and here two functions are with two arguments and two more functions with three arguments. Okay, but they are differ. First two arguments are int and float, and the two functions with three arguments are int and float. Okay, so they are differ. We are declaring four functions. Among those four, two are having two arguments, but type of those arguments are differ. That is int comma int, float comma float. And two more functions with three arguments. The number of arguments is same, but the type of the arguments are differ. int comma int, float comma float. Okay. In main, of course, if you want to read the data at runtime, you can declare the at least 3 integers and 3 floats, and read values at runtime for these 3 integers and 3 floats, and pass them as arguments to the function based on your requirement, or based on to which it has to match. Okay, to which it has to match, that depends upon you. That depends upon you. So here I am directly passing the values. For the first one, add 2 integers 20, 30, and for the second one, add 3 integers 19, 23, 16, and for the third function, add integer of course, but one float. Okay, and add 3 floats. So if you consider the third example, that is third function called add 16, 7.7. So if anything like this, the compiler what will do first, normally when there is functions in our program, first the compiler try to match the function call with exact match of the function definition. Okay, for example, if this is the case, add 20, 30. So here the name of the function add, and 20 is an integer and 30 is also an integer. So when we execute this particular program, the compiler tries to match with a function whose name is add and which is having 2 integers as its arguments. Okay, if there is no exact match, okay, then it search for some other function definition which may match to this function call. So in this case, that is third example, add 16, 7.7. So here 16 is an integer and 7.7 is an float. 7.7 is a float. Okay, so normally here the compiler, when the compiler encounter this particular statement, it tries for the function name add. So in our program, we are having 4 add functions. So next it examine the first argument as integer. Okay, so here it checks this is an integer, and the second argument is float. Okay, so here we are having float. So either this can be executed or this can be executed. Okay, so that depends upon the compiler. That depends upon the compiler, because this integer can be treated as float. If the compiler treats this integer as float, then it match this function call with this function definition. Obviously, in this case, the compiler match this function call with this definition only, not with this definition. That is first one. Okay, why? Because if it match with this 7.7 with the integer, obviously we may lose this 0.7 value. Okay, so when the compiler tries to match with the function call with the function definition, it will even takes care about minimal loss of the data. Minimal loss of the data. So if it matches with this float comma float, obviously there is zero loss of data. Zero loss of data, because 16 point here, this 16 will be treated as 16.0. That's it. And 7.7, of course, that is a float. Okay. So here the compiler matches this function call with this function definition. Clear? So though we have written some other, if we pass some other data in which there is no exact match, then compiler tries to match with the nearby function definition with minimal loss of the data. Okay, that also happened in function overloading. So here we are declaring 4 functions with different arguments, different number and different types of arguments, and based on that here we passed values. Okay, now we need to define each and every function individually. First one is add function with two integers. So what it do simply, it is taking one more variable, that is z of type int, and it is adding these two values, okay, in this z, and it is printing the z. Okay, and second function definition, add in three integer variables. So it is taking one intermediate variable, that is z, which stores a plus b plus c, and it is printing that value. And likewise third function with the two floats. Now it takes one more local variable z, and it stores that expressed by this addition of these two float values into z, and it is printing that. And even with three arguments, okay, of type float, again it adds this a plus b plus c and storing into one another intermediate variable, and it is printing that. Instead of writing here these two statements, that is totally three statements, even you can overwrite these three statements using only a single statement, that is cout. The sum is directly a plus b plus c, instead of storing a plus b plus c result into the variable z. Okay, you can directly write here a plus b plus c. Okay, now we will execute that program. New hash include stream and hash include conio and directly we need to declare the functions. Okay, that is void add int int and void add float 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 and void add int int with three arguments. Void add three floats, float float, and main main. Okay, I am directly passing the values. Otherwise, if you want, you can declare some local variables and pass dynamically or runtime at runtime. Add two floats, 2.5 comma 3.5. Okay, add three integers, 10 comma 20 comma 30. Next, add two floats, 2.5 comma 3.5 comma 4.5. Okay, as your wish. And get ch, return 0. Okay, even I want to provide some clear screen. All these things you have to habituate. Okay, this is the end of the main, but we need to write the definition for all these functions. Add int a comma int b. Okay, so directly I am writing in a single statement the sum of two ints, integers, otherwise integers, is what has to print a plus b. A plus B and L. Okay, close of this. Void. Second one is add two floats. Float A comma float B. Again, directly I want to print the sum of two float numbers is A plus B again. A plus B. Close of this. Next word, add three integers. Int A comma int B comma int C. I am taking one variable, that is sum, and s equals to A plus B plus A plus B plus C, and C out sum of three ints. I'm not writing everything, you can able to understand, that's fine, that's the reason, and even to save the time. Okay, close of this point, add with three floats. Float x comma float y comma float z, and float s is equals to x plus y plus z. Okay, see out sum of three floats s. Most of this. Okay, save the file. Function overloading. Function overloading 1. Okay. Compile the program. I don't know how many errors it will return. Two errors, ambiguity between add int float. So, though there is a direct in a that is direct exact match. Okay, even the compiler is saying that there is a ambiguity between these two variables. Okay, these two variables. So simply comment that. Simply we need to see. Okay, I'm commenting float float int 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 float float int int int. Okay, this also. Even there is a direct match. Okay, the compiler is having some ambiguity. Okay, so here our intention is simply to show even that is possible that if in a program we may have more than one function with same name with different number and type of arguments. Okay, alt, run the program. See, the sum of two integers is 30 and sum of three floats is 10.5. 10.5. Here, this is 2.5, 3.5, 6, 6 plus 4.5, 10.5. 10 and 20, 30. Okay, even you can change this also int. Okay, save, compile the program. no errors. Okay. Though here we provided as third type of the argument is int, and here we are passing one float. Okay, we are not getting any error. Run the program. At runtime we are getting some error, that is undefined symbol add in module. Okay, if that is float, and if this is integer, what happens? Save the program and compile the program. No errors. Run the program. Floats is 10, integers is 30. See. Okay, that is in previous case, that is when we provided here int and here float value. Okay, the float cannot implicitly converted into integer. That's why though there is no error at compile time, we got error at runtime, that is at the time of execution, because implicit conversion is not possible from float to int. If we are passing integer and the definition is having some float, this integer can be implicitly converted to float. That's why we are not getting any error at compile time or at runtime. Okay, so likewise normally the compiler try to match the function call with function definition, but this is the case where the compiler is providing some ambiguity. Okay, this is end of today's lecture. We will continue in the next lecture. In today's lecture, we have seen how a friend function can return an object as its return value, and what is meant by polymorphism, what are the different types of polymorphisms, right? And what is function overloading. Okay, we discussed in today's lecture.